absolute value equations. Those came up when you were going through some of that SAT stuff, so we've talked about it maybe a teeny tiny bit, but just want to make sure I hit some of the other, make sure you do this, don't do this kind of thing. So on number 1, it says if the absolute value of x equals 7, what are the possible values of x? What could x be? 7 and negative 7. Everybody agree with that? Because the absolute value means whatever's inside of it, whenever you're done doing whatever it is, it comes out positive, whether it was positive or negative. So what about the absolute value of x equals negative 4? What could I put in there so that when I took the absolute value, I'd get a negative number? Is there anything I could put in there? No, because if you take the absolute value, it's literally always positive, right? So this is none. There are none, which means that here there is no solution. So if I recognize that at the beginning, I won't have to actually work through some things, depending on, what it is. I don't have to work it all out. All right, so your steps to solve. Want to make sure that step number 1 is really the one that sometimes we miss because we haven't thought about them in a while and then we do weird things. You have to isolate the absolute value expression, and I will explain to you more what that means as we go through these. Then we create 2 cases. You set the inside equal to the positive and negative value. That's why this answer here is pretty much doing that. We take the x, we set it equal to 7, and we take x and we set it equal to negative 7. And then we solve if we need to solve. In that case, I just didn't need to solve. Now, this is kind of not really the right steps. It's probably how you were taught. It's how I'm going to go back over it with you. But I am going to show you, just because it bothers me when I don't teach you the 100% right thing to do, because it makes a difference if we're doing inequalities. So I'll point that out to you when we do this first example down here. But then you solve them, and then you have to check for extraneous solutions. What is an extraneous solution? Anybody know? You had to check for extraneous solution with things like logs. And what would happen? Sometimes you plug it back in and what? It wouldn't work, right? That'd be your extraneous solution. So what are extraneous solutions? They are solutions that don't work when substituted back in. Okay. But here's the good news. Even when you first learned this, maybe your teacher made you check on every single one of them. You don't have to check for extraneous solutions on every single absolute value ever, only on specific ones, and I'll tell you when we get there how you identify that. But we're going to start with a super simple one, number 3. Okay. Now, what the directions say is to isolate the absolute value expression. That's what that is. So it is isolated. Then we take the inside, which is x minus 9. We set it equal to whatever's on the other side of the equal sign. And then we take the inside and we set it equal to the negative version of that. Now, here's the thing. That works, and that's totally fine, and that's the way I would do it myself. But again, the official directions, or the official way to really do this is do like x minus 9 equals 5. And then what we're taking the absolute value of is the inside there. So then it would be negative x minus 9 and set it equal to 5, right? So officially, this is what we're supposed to be doing. And then once we get here, if I multiplied through by a negative 1, I'd end up with this. So that's why it works out just fine. The reason you need to know that this is really the way to do it is because if this was an inequality, then when I multiply through and I have, remember inequalities look like this, right? I'd have to, if I multiply or divide by a negative, I have to flip the sign. So when you're doing these with inequalities, you have the sign should match on the one that you leave like it is, and then you'd have to flip the sign around on that one so that you don't have to go through these steps. If you want to ignore everything I just said in blue, that's fine, and know what to do in pink. I just always feel like I need to have a little disclaimer there so that if you see it done a different way, you don't think that that way's wrong or that I taught you wrong, that there are different ways to do things. But then once we get here, this is a piece of cake, right? X equals 14. And x equals what? 4. two answers. Okay. Everybody okay with that? Any questions? All right, so we have to know when we can drop our absolute value signs. Right here, I got to drop it step 1. Do I get to start on, we're going to skip number 4. On number 5, do I get to just drop my absolute value signs? No, because I have to isolate this. So you do the same algebra steps you've been doing for everything else. You got to move that 17. How do you do that legally? Subtract. So I have the absolute value of y minus 1 equals what? 6. Now can I drop them? Yes. So I have y minus 1 equals 6, and y minus 1 equals negative 6. Y equals 7, and y equals what? Negative 5. Any questions at all? All right. Let's talk about what we can and can't do on 6. Can I drop the absolute value sign right now? No, because I got that 3. Here's the other thing I cannot do. I cannot distribute it. Those are not parentheses. The stuff that is inside the absolute value stays stuck together in that absolute value until it's isolated and you get to drop them. So no distributing that 3. That's a big fat no-no. But how can I move the 3 legally? Divide it. I can divide both sides by 3. Which is probably what most of y'all would do at this step anyway, not really think about it. But I've seen distribution happen when it's not supposed to happen. So we got to make sure we know what to do when. M plus 8. 39 divided by 3 is 13. Also, when you're doing absolute value sign, absolute value, make sure you know that what your absolute value sign looks like. You don't think it's a 1 and you're not confusing yourself. Okay, because I see that too. You just start to confuse yourself. So M plus 8 equals 13 plus 8 equals negative 13. So I get M equals, what's 13 minus 8? 5. And negative 13 minus 8? Negative 21. Very good. Okay. What questions do you have? All right. Let's look at 7. What do I need to do first? Divide. We'll divide both sides by 16. Those cancel out. Absolute value of r minus 5 equals a negative 2. Do I need to do anything else? No. Why? Negative value. Once I have this isolated, if I'm supposed to take the absolute value of something and it's supposed to be negative, that's impossible. So this is no solution. If I actually wrote it out and kept doing those other steps, I'd get solutions, but I would be wrong. So catch that and you're good. Everybody good? Okay, so on number 8, I kind of wish I had changed this question a little bit. I wish I had made that 2y, but I didn't. Even if this was 2y, I would not be able to cancel out the 2 in that fraction. The reason I can't cancel it, I mean, yeah, I also can't cancel it because there's not a 2 on the y. But even if there was, I can't because it's inside that absolute value. It's kind of like trying to cancel it out with a square root. Like none of that's legal. I have to isolate that absolute value. So what should I do first? Multiply by negative 2. I'll multiply both sides by negative 2. Those are going to cancel out. The absolute value of y minus 10 equals a positive 12. And notice before I had that equal to a negative 6, but I didn't get to stop right there. You have to isolate it first. Now it's equal to a positive number, so I can keep going and get y minus 10 equals 12, and y minus 10 equals negative 12. Any questions at all? We good? All right. Flip it over. I think we can skip number 9. Let's go to 10. So on 10, let's see, 3, 12, and 9 are all divisible by 3. Can I reduce the fraction on the left? No, because that's inside the absolute value. So what should I do first? Multiply both sides by 9. If I do that, those cancel out. It's the whole reason I did it. Absolute value of 3a plus 12. What is 0 times 9? 0. Okay. I can't have it equal to a negative, but I can have it equal to 0. So now I'm going to get 3a plus 12 equals 0. Would negative 0 make any sense? No. So this is 3a equals negative 12. A equals negative 4. And I only have one answer. All the other ones we've had 2 answers. But I want to remind you that you could have 0, and we've also had 0, right? So if I have 2 answers, my graph would look something like that. If I have 1 answer, it's going to look something like that. If I have none, it would look something like that. Okay? So when you get no solution, it's not crossing the x-axis at all. When it's 1, it's just the vertex of it that's on there. And then we've got that. Okay, we good? Questions? All right. Let's look at number 11. Now, I don't know that some of y'all would do it right here necessarily, but I've seen it done a lot. If I wish that I'd put 9 after the absolute value, because then I would see people just go ahead and divide both sides by 4, and we can't do that until this term right here is isolated. Does that make sense? Like, I know y'all know that, but then these are weird things that happen. So what do I have to move first? The 9. So I'm going to subtract 9 from both sides. That'll leave me with negative 4. The absolute value is c plus 10. And then negative 15 minus 9 is negative 24. All right, you go ahead and finish that one up. Negative 4 and negative 16? Yes? Okay, good deal. Now, on number 12, I know there are, we've done some things where, let's get rid of that fraction. I cannot clear the fraction right here because it is inside that absolute value. So multiplying through by 5 is not going to do anything for me except make all my numbers bigger. All right, so cannot do anything with that now. Instead, I've got to isolate this first term, so I got to move that 8. So I'm going to subtract 8 from both sides, get negative 24 equals negative 12 times the absolute value of k over 5. I still can't get rid of the fraction, but it's not that big a deal. Right now, I'm just having to rewrite it. What do I do next? Divide by negative 12. Good. So I'm going to get 2 equals the absolute value of k over 5. So now the absolute value k over 5 equals 2, and k over 5 equals negative 2. You can flip it around, but you don't have to. Then you're going to get k equals 10, and k equals negative 10. Any questions at all? All right, now look at 13 and 14 and tell me how they are different than 11 and 12. There's variables on both sides, okay? And not just, okay, and they are, all the rest of these are variables on both sides. It doesn't necessarily have to be on both sides to be this situation. These all just happen to be. But I have variables inside the absolute value and outside the absolute value. Because look, if I had this minus x, they could all be on one side. So But if I have a variable inside and outside, this is where I have to check for extraneous solutions. Okay. The rest of them I didn't have to. I could, and I could check myself. But if you have variables inside and outside, that's when you have to check. Okay. So let's get this one done. I have this isolated already. And here's the other thing you have to be careful with. We take what's inside, 3x minus 9, and we set it equal to x plus 1. Then I take, again, what's inside, and I set it equal to the negative version of that, and I have to put parentheses because I'm putting the negative in front of more than one term. Those are the mistakes that happen that are bad, bad, real bad, okay? So then I just solve these. This will give me 2x equals 10, x equals 5. Here I get 3x minus 9 equals negative x minus 1. Okay, careful with those negatives. So this will give me 4x equals 8, x equals 2. Everybody with me so far? Okay, so now I have to check myself. So we get the absolute value of 3 times 5 minus 9 equals 5 plus 1. So this is the absolute value of 15 minus 9 equals 6. Well, 6 equals 6, so I'm good. I like that one. Okay. Then I've got the absolute value of 3 times 2 minus 9 equals, and notice I have to put it back into the original. That is equal to 2 plus 1. So this is 6 minus 9. No. What did I do wrong? Did I do something wrong? No, that's right. 6 minus 9. I'm sorry, I'm having a moment there. That's the absolute value of negative 3 is equal to 3. Is that a true statement? Yep. That's 3 equals 3, so x equals 2. I was trying to get 6. In my head, I was like, why am I not getting 6? That's what I kept thinking. I didn't need to get 6. I just needed this to be a true statement. Ask me questions. What's your question, Lauren? Are you sure? Okay. Anybody else? We all good? Okay. All right. We're going to do 14 because some of these that we're going to do some fraction stuff here. All right. Can I start by dropping these? No. Can I distribute that too? No. What do I need to do? Divide. So absolute value of h plus 8 equals 7h. So now h plus 8 equals 7h. And h plus 8 equals negative 7h. So I'll give me 8 equals 6h. 8 over 6 equals h. H is equal to 4/3. And I promise you, you absolutely do not want a mixed number or a decimal here. You want that fraction. That's going to be by far the easiest thing for you to deal with. Then over here, we will get 8 equals a negative 8h. So h is equal to negative 1. So those are my two answers that I have right now, and I need to check them. I'm going to come over here in this column where I have some room to check them. Check number 14. Okay, I'm going to start with that 4/3. So 2 times the absolute value of 4/3 plus 8 equals 14 times 4/3. Now, I've got some options here on how I can manipulate these numbers, but what I'm afraid of is that I might totally lose some of you if we talked about those things. So, because I could move the 2, but I don't want you to make up math and some other things. We'll just leave it there for right now. But what I can't do, again, is I can't clear my fraction, right? And so I'm going to have to deal with it. Oh, sorry, my 8 looks weird. I'm going to have to deal with it. So I've got 4/3 plus 8. If I look at that as 8 over 1, what would my common denominator be? Between 4/3 and 8 over 1. What's the common denominator? We just do this up here separately. 4/3 plus 8 over 1. It's not a difficult question. What's my common denominator? 3. Okay, which means I need to multiply this by 3 over 3. So then that's going to give me 4/3 plus 24/3. So that 8 over 1 became 24/3. Now I have a positive number plus a positive number, and then I'm going to take the absolute value. So really, do I need my absolute value sign anymore? I don't, right? So this is just 2 times 24 over 3 equals, then this is like 14 over 1, which means my denominator is going to be 3. I have to do 14 times 4. Oh, it's 28. God, you know what? I did that second period too. It's 28. I didn't actually add them. You have to add them. Sorry. 14 times 4/3. So 14 times, what's 14 times 4? 56. What is 2 times 8? That was 2 times 28. 56. So this becomes 56 over 3 equals 56 over 3. We like this one. Okay. Questions? You can't zone out and ignore fractions, right? Then I got to check this -1. And I get 2 times the absolute value of -1 plus 8 equals 14 times -1. So this is going to be 2 times the absolute value of 7 equals -14. Well, that's going to be 14 equals -14. Is that a true statement? No. So we do not like that one. And remember, you have to substitute it back into the original one, not one that you have already manipulated. Okay. What questions do you have? Anything? Okay. I don't think we need to do any more. I think that's probably enough. Do we need to do 15? No, y'all got this, right? Okay, good deal.